Hello, students. Welcome to Talk on Civil Engineering. Let us solve one problem from losses of pre-stress in a post-tension member. So here you have a question. So let us try to solve this question. Okay. So firstly, let us write the given data from this question. So here the type of member is a post-tension member. The post-tension member. And he has mentioned the size of it. Span is 10 meters. And it is having a cross-section of 200 mm into 450 mm. So L is 10 meters. And size of it is 200 mm into 450 mm. Okay. So this is breadth and this is depth. And what else he has mentioned? He has mentioned the prestressing force, that is capital P is equal to 300 kilonewtons. And it is having a constant eccentricity. E is equal to 75 mm. Okay. The constant eccentricity in the sense the tendon is straight. It is placed straight. Okay. And he has mentioned the tendon is having an area of 250 mm square. So area of steel, AS in the sense area of steel, that is tendon, it is having the area of 250 mm square. Okay, and what else he has mentioned? And is asking to find out the total loss of pieces in the tendon. And what is ES? He has given ES value. Young's modulus of the steel, that is 2 into 10 to the power of 5. So this is 10 to the power of 5. And EC value, Young's modulus of concrete, that is 35 kilonewton by mm square. Okay, and he has given the anchorage slip value also. So we mentioned with delta S, that is 3 mm, and creep coefficient value, that is 1.5, and shrinkage strain is equal to 0.0002, and relaxation of steel is equal to 2%. Okay, so for this we need to calculate what is the total loss in this member, total loss in the tendon for this post tension member. Okay, right. So before solving this problem, we need to know what are the losses will be there in a post tension member, because he has given this member is a post tension member. So for post tension member, we are going to have 5 losses. Okay. So what are those losses? So we are going to have 5 losses. One is loss due to creep, and loss due to anchorage slip, and we'll have shrinkage, loss due to shrinkage, and 4 due to relaxation of steel, and 5 due to friction. Okay, so these are the 5 losses we are going to have in post tension member. Okay, the summation of these 5 will be the total loss of pre-stress in the tendon. Okay, so let us try to find out what is the loss of pre-stress for each of this loss. Okay, now let us find out the stress due to creep of concrete, loss of stress, loss due to creep of concrete. Okay, so for this, we the formulas we are having is, so here in the question he has given the creep coefficient. Okay, so we need to use the formula related with creep coefficient. So that is creep coefficient into FC into alpha. Okay, in case he has given the ultimate creep strain, then we are going to use the formula, that is ultimate creep strain into FC into Young's modulus of concrete. Okay, so this is a formula we are going to use if the strain is given. Okay, so here in this question he has given the friction creep coefficient, so that's the reason we are going to use this formula. Okay, so in this question the FC is nothing but So in this question, firstly, let us find out what is FC. So FC is a stress in concrete at the level of steel. So stress in concrete at the level of steel. So let us find out this. So firstly, direct stress, that is P by A. So here area of concrete we need to take. Plus due to the tendon profile, we'll have the stress due to the tendon profile, that is P into E is the moment divided by I into E. So that the y distance. So this y distance we have to take the eccentricity, that is we are finding the stress at concrete, stress in the concrete at level of steel. So that's the reason we are taking the eccentricity of the steel. Okay. So let us distribute the values. So P is 300 into 10 to the power of 3. Area of concrete is 200 into 450 plus 300 into 10 to the power of 3. E value is 75. And moment of inertia for rectangular section, it is BDQ by 12. We know that. So B is 200, depth is 450 cube by 12 into 75. Okay. So now calculate this value. You will get the stress in concrete will be around 4.4 Newton per mm square. Okay, so we got FC value. This is FC value. Now let us find out what is alpha E. So alpha is nothing but the Young's modulus of steel divided by Young's modulus of concrete. Okay, so substitute the values. Young's modulus of steel has given as 2 into 10 to the power of 5, and Young's modulus of concrete has given as 35 kilonewtons per mm square. So we need to convert this into newtons. So 35 into 10 to the power of 3. So we calculate this value, we'll get a value around. Calculate this, you'll get a value around 5.714 is the alpha E. Okay. Now substitute these values and calculate what is the loss due to creep of concrete. So the creep coefficient is 1.5 as given in the question. FC just now we have calculated, it is 4.4, and alpha E is 5.714. Okay. So put these values in calculator, you will get a value around 37.7 Newton per mm square. Okay. Now let us find out the second loss, that is loss due to anchorage slip. This is the Young's modulus of steel, that is 2 into 10 to the power of 5, and delta S is the anchorage slip, that is 3 mm he has given in the question, and L is the span of the member, that is 10 meters, and we need to convert this into mm. So multiply with 1000. So it will be 60 Newton per mm square. So this is a loss due to anchorage slip. Okay. Now let us find out the loss due to shrinkage. Loss due to shrinkage. Okay. So here the formula we are going to use is the ultimate shrinkage strain into ES. Okay. So what is the ultimate shrinkage strain? He has mentioned in the question. It is 0.002. So 0.002 into ES value is 2 into 10 to the power of 5. Okay. So it will be 40 Newton per mm square. Right. So now let us calculate. So what is the loss due to relaxation of steel? Loss due to relaxation of steel. So this loss due to relaxation steel just simply will take some percentage to the initial stress in the steel. So if he is not mentioned in the question, so we'll usually take 5%. If he has mentioned in the question, we'll take whatever the percentage he has mentioned in the question, that will take as the loss due to relaxation. So in the question he has mentioned it is having 2% loss of initial stress in steel. So for that reason, we need to find what is the initial stress first. Okay. So let us find out what is the initial stress. Initial stress in steel, that is the tendon. Let us represent this with P naught. Will be equal to P divided by the area of steel. Okay, load by area will give you steel, will give you the stress. So P is 300 into 10 to the power of 3. I'm writing in newtons, and area of steel has mentioned in the question, that is 250 mm square. Area of steel in the sense the area of tendon. Okay, so if you calculate this, you will get the value of 1200 Newton per mm square. Okay, so this is the initial stress, and for this stress we need to take 2% as a loss due to relaxation of steel. Okay, so 2 divided by 100, so loss is equal to 2 divided by 100 into 1200, so which will be 2 times of 12 will be 24. 24 Newton per mm square. Okay. So 5 losses we have calculated. Now let us calculate the fifth loss, that is loss due to friction. So if you observe in the question, he has not mentioned any data regarding the friction, but we need to calculate the loss due to friction because it is a post tension member, so it will have the loss due to friction. Okay, and one thing we can consider as the data, that is the tendon profile is straight. So that he has mentioned it is constant, it is having a constant eccentricity, that means it is straight. Okay, so now let us find out what is the loss due to this friction. So firstly let us write out the formula. So loss due to friction is equal to P naught, that is the initial stress in steel, into mu into alpha plus K into X. Okay, so here this alpha is the slope of the tendon. So here this is a straight tendon. So there will be no slope. So therefore this value will become 0. Okay, so because there is no slope. Okay, and K represents the wobble effect. Wobble effect, or we also call as wave effect. Wave effect in the sense that it means that some unexpected profile change. So we know we are providing the straight, but we can't ensure that the tendon is straight enough. Okay, so there will be unexpected deviation in the profile. So for that reason, we'll take the K value. Okay, so the K value, we'll be considering that it will be 0.0015 per meter. Okay, so X is the span of the member. Okay, so let us substitute the values. P naught is 1200. Okay, so this value will be 0 plus K is 0.0015 and X is the span of the member, right? So it will be 10. Okay, so here this is in meters and this is in meters, so meter will get cancelled. Okay, so that's the reason I have not converted this into mm, right? So now calculate this value, so you'll get a value around 18 Newton per mm square. Okay, so suppose if the tendon profile is not straight, it is some parabolic or some incline. So in that case, you need to consider this value also. Okay, so you'll have alpha value, right? So we have calculated all the 5 losses. Now let us sum up all these 5 losses. Okay, 5 losses. So the loss will be we got the value around 37.7. And the loss due to anchorage got value 3. Remember, okay. And the loss due to shrinkage we got 40. Remember, loss due to loss due to friction. The total loss of tendon in post tension. The total loss of tendon. So the question has asked to find out what is the total. The question is asked you to find out what is the percentage of loss. In that case, we need to find out the percentage of loss. So let us see how we can find the percentage of. So we know the total loss is 178.7. And what is the initial stress in the tendon? So the initial stress in the tendon is 1200, right? So divided by 1200. The loss of percentage of loss of the tendon 14.9%. How we are going to find out the loss of